In TC1101, we covered this topic from the perspective of using TPM2 tools and using the Wolf TPM stack. While the information is the same because it is based on the TCG specification, perhaps it is good to go over these details and just focus on the different types as set by the TCG. That being said, I really encourage you to go and watch Lecture D from TC1101 because it covers exactly this information from a different perspective that is easier to understand. When creating a new primary key or a child key, we need to provide the public key parameters that are stored in a TPM2B public structure. This structure has two elements as any TPM2B structure. It has a size field and it has an element that holds the information called, in this case, public area of type TPM-T public. Let's take a closer look. So TPM-T public has 6 very important elements. The first one being type. As the name suggests, this provides the key type, usually RSA or ACC, and we'll take a closer look in a moment. Then we have something called name algorithm, which is typed name ALG as one word. And as you can see from its type, TPMI underscore ALG underscore hash, this is actually an identification for a hash algorithm. Why? Because name ALG sets the hash algorithm to be used by the TPM when it computes the key name. Then we have object attributes, a very important part of the key properties. It actually defines what the key can do and cannot do, including what is the authorization. Is it a password authorization? Is it a policy authorization? Is it both? And we have a dedicated slide on this in a moment. And here comes the out policy field, which is a digest that enables the extended authorization that we will discuss in lectures H of this course, TC1102. Last but not least, we have different key parameters depending on the key type. If we have an ECC, naturally, we would have to specify the curve. If we have RSA key, we need to specify the size of the key. And if it's a symmetric key, we need to specify the symmetric algorithm and perhaps its mode and its properties and so on. Last, we have a very interesting field, as the name suggests, unique. This field enables us to add user entropy when creating primary keys. And this field varies depending on what is the key type. For example, if we have an ECC key, then this field holds curve points. If the key is RSA, then it holds a seed input and the values inside of are of type TPM2B. And all of these can be found in the TPM library specification part 2 structures. I really recommend taking a closer look there. Let's quickly go through the common types that we can use when populating the TPM public parameters. And in this case, we'll talk about the type, name algorithm that's used, and parameters. We'll give, of course, 2 examples with ECC and RSA. So we have the RSA key set using TPM underscore ALG underscore RSA, and similar for ECC, TPM underscore ALG underscore ECC. We also can have a symmetric key or a different type of keyed hash key, and these are also covered in TC1101, so I would recommend just taking the labs there as well. And here are the 2 examples. First, ECC. When we have an ECC key, naturally we need to define the curve ID. And on the next slide, I've shown different IDs for the different ECC curve types. And this information is available in the TPM specification that is mentioned in the previous slide, and also we'll mention a few more times here. So there's nothing special about these parameters. It is just important to get it right, that the hashing algorithm for the name can be anything that is supported by the TPM. So it's really up to the developer. Of course, we need to set the type as the one for ECC. And again, the most important bit naturally is the curve. I just want to demonstrate here that setting these parameters is the easy part of the equation, and the object attributes that we'll discuss in a dedicated slide is where we have to be very careful. So the RSA example, also we have the type definition as in the TCG spec for RSA. Then we have selected SHA-256 as the algorithm for the name computation. And at the end, we have the size of the RSA key. Nothing special really. We just have to be careful for typos, I guess, at this stage. So let's continue. The full list of options can be found in the TCG library specification part 2 structures. And I want to highlight TPMI AOG hash and TPM ECC curve, as I expect that this will be highly used during TC1102. And here are some examples. So if we want to use a different curve, for example, P512, we can just do that. But remember, we have to also check the capabilities of our TPM. And we covered this in TC1101. We covered how to get the capabilities of our TPM to check what algorithms are actually supported. So I really encourage you to take that course. Then we have common values for hash algorithms. Of course, these are just the most used ones. Again, your TPM can support more options. And for the full list of available options, I recommend reading the spec. Usually for the name computation, we use SHA-256, but of course, having a larger size algorithm and digest doesn't hurt. And we can use SHA-512. Most modern TPMs support it. Just make sure to check. Of course, when running your application and testing, you would find an error if the algorithm is not supported. Now, for the symmetric algorithms, which are kind of out of scope in this course, we don't use them really, but we did in TC1101. I just wanted to specify the two most used ones, which are AES and the Chinese variant SM4. And of course, when using symmetric algorithms, we have different modes. And these are not all of the available modes according to the spec, but again, we have to check with the capabilities of our TPM. Naturally, you would recognize, if you've taken TC1101, the CFB mode here, because combined with AES, we use it for parameter encryption that we'll cover in the lectures here, how to do that using eSAPI. Moving forward to the object attributes, which are really interesting. And this is a slide from lecture DFTC1101, no surprise there. I really encourage you to listen to that lecture. Here I will focus on two sets of important attributes because they're very well covered in the official specification from the TCG in chapter 8.3, table 31. And here on the right, we have a screenshot of that table. Not a complete view of the table, but the most important bits of it. And I want to point your attention to the last two attributes here. TPMA object user without instructs the TPM to look for password authorization. TPMA object admin with policy instructs the TPM to look for extended authorization that we'll learn in this course, TC1102. And be careful when you select these attributes, because if you select both, this means that the TPM will accept either. It's like an OR. And also when setting these attributes, you would view in our examples as well in our lab solutions that they are being concatenated using OR in our C code. So another interesting part of the attributes here is TPMA object decrypt and TPMA object sign. So the name might not be intuitive, and I see that it's not visible in the screenshot here, but the TPMA object decrypt enables the TPM to use that key for decryption and encryption, while TPMA object sign, as the name suggests, enables our TPM to perform digital signatures using our key. And this is also important, you'll see in our next lectures when talking about the endorsement key, that if we use the TCG templates, then the TPMA object sign attribute is not allowed. And I really encourage to take a closer look on the specification.